and that information is read. Beyond that, everything else remains the same. So for example, if I'm reading an ETABS file, I'll read this MDB file as an access database file. I double click on that and reads the file. I'm doing beams. So I can select beam and select the level that I want. Let's say I want to do level story 1. I say OK. So it goes into this, the file, reads the information, and more importantly understands and identifies the design continuum. So what it is trying to do is understanding what is a set of continuous beams. So we believe that all continuous beams should be designed in detail together, so you can take cognizance of the continuity for design. So here the software automatically identifies that this is a set of continuous beams, this is a set of continuous beams, or this is a set of continuous beams, and so on. So you can see it's already grouped them, saying one group of continuous beams is, say, this beam number 36, 37, 38, 39. So it identifies that continuum and designs that continuous beams together. So you can take, as I said, cognizance of continuity, etc. Or if you see another view of the same information, you can actually see the beam column continuum that the software has identified from the geometry that it has read. So this identification of this design continuum is done by the software automatically as it reads the design input. We can then go in and set the various design settings. So I can define a material properties. So let's say I have M30. I can set the diameters, minimum maximum available, minimum maximum percentage steels, etc. And I can also, if I wish to, ignore torsion. Now this is a contentious clause. Some people like, especially in style, are only able to provide rigid diaphragms. Despite that, there will be some torsion in the beams, and they would say, okay, there's actually going to be a diaphragm, there's going to be a slab, I want to ignore the torsion. So that is the user's prerogative. If the user wishes to, he can ignore torsion by clicking this button and defining a value of the torsion less than which it should be ignored. So if I say ignore torsion less than 5 kilonewton meter, so any torsion which is 5 kilonewton meter or below, which is to me relatively insignificant, will be ignored by the software. All other torsion will be considered. So it's a user's choice. If he wishes to, he can do so. By default, we never suggest it, so we rather say you release this or take care of it in analysis. That's the way we interpret that. But I just say okay. I can also set other design and detailing settings. So I can define a curtailment settings. So what is my top steel curtailment location, bottom steel curtailment location, the shared zones for ductile beams and non-ductile beams, the factor of depth or factor of length, etc. I can also go in and set how many bars do I want in a beam of a given width. So I can say a 230 mite beam, and it is also split into two zones. So smaller diameter bars up to 16 and larger which are 20 and more. So I can say, smaller diameters put 3 bars, larger put 2 bars and beyond. And for each of those, this spacing criteria is also mentioned here. So if I can keep changing this, you'll find the spacing also changes by itself. So you can control it and say, no, I want only 2 and here I want 3. So you can equate and say I want to provide the same, whether it's a small diameter or large diameter. So the user can control all of this. He goes into a design, and like before, we just associate the load cases. Just say okay, I say add from analysis, and the software will now design and detail the entire set of continuous beams. So all the beams will compute the forces, find out the and load envelopes, and design. So each of the beam has got design, and you can actually see the design output in itself, where for every group you can see the beam number, the type of beam, is it a ductile beam or it could be a regular beam like this here, which is a non-ductile beam. If it's a cantilever beam, it will identify that. The size of the beam, this bottom steel in 3 zones, the top in 3 zones, shear reinforcement in 3 zones, face reinforcement, and ductile diagonal reinforcement if this is a coupling beam between 2 large shear walls. So this is the basic design that the software has suggested based on the settings that we have provided. Now the user has the freedom to edit all of this. So if I want to edit, let's say, the reinforcement of a given section, I can just come and double click here. This window will open up where I can try some other options. So instead of, let's say, 416 and 212, I want to try a 420. So I can say give me 420, and you'll find the area of reinforcement keeps on changing as I change the numbers here. Now I'll say 420 seems to be fine. Okay. Well, I'll say I want to try 320. Will that be enough? That seems fine. So I say, okay, let's go with 320. I accept it. So the section here becomes 320. Then I can move on to the next section and so on, or into shear reinforcement, and this window changes and displays you, allows you to edit shear reinforcement in one shot. So any section can be edited by just clicking on that and invoking this window. And the reinforcement, it's also trial and error. You can try various combinations. It will check for sufficiency of reinforcement. It will check for minimum, maximum, bar spacing, etc. So all the codal requirements are taken care of by the software in itself. Now once I change one section and I want to, it's a bottom steel, so I want to say I want to apply 320 all across. So I can, like in columns, just do a copy reinforcement and let's say select here or all of those and just say paste the reinforcement. So it will go and change all across. So it will obviously, like in columns, it's an engineered copy paste. So check for the sufficiency of the pasted reinforcement, and if it is sufficient, apply it as we've seen. One important facet that we always notice is when engineers are working with beams, and beams, you tend to work with multiple sections and the beam lengths vary. So it's very difficult for engineers without WorkX to get a feel of how the elevation actually is going to pan out once they design it. So to aid that, we have given a tool here, it's called quick elevation, wherein during the design stage itself, a proper to-scale elevation can be generated of the current detailing. So here you can see that at the bottom of the screen, it has generated the current detailing as specified by us. So the user gets a very, very good feel of how is this detailing actually going to pan out once it gets drawn or when it's going to get executed. And this is a sketch which can be saved. So I can just come in and save this here. It becomes a DXF drawing. I can open it in CAD. I can share it with anybody I want. So that information, that freedom is also available to the user. There are a few more detailing options. One was when we did a section at a time. So we double clicked on the section and worked with that. Now in case I want to do a typical kind of detailing across an entire beam group. So let's say I want to design here all the beams with 25 die in the first at the bottom and 20 die at the top. So if I want to do something of that sort, I can right click and go to this tool called quick detail, and I can say I want to do bottom steel 25 die and I say top steel 20 die and I select it. When the moment I do that, the software will detail with the information that we provided. So here you can see all the bottom gets detailed with 25, top gets detailed with 20 as required. So that's why we didn't specify a number. So it's evolved a number as per the requirement of the detailing in itself. So you can control detailing across at a section or across an entire beam group using these tools. What you can also do is rework the design itself by changing either material properties or member properties. So I can right click and say detail, go into design, and here I can change the material properties, the clear cover, the number of layers of reinforcement that I want to work with, the size of the beam, etc. Editing can be changed. You can redesign it. So I can, let's say, design it with M25 and see what happens. So I click on this. It gives me a new design with M25. If I'm comfortable, I can say accept, and that information gets stored in here. So I can redesign, change material properties, etc. And there's another interesting tool which I think we should see. If I go to something known as detail, I'll just open another beam where I can show you a very good variation. Yeah, this is a good beam. Now this is a tool called detail. What you can see here is the detailing of the beam at multiple sections along the length of the beam. So this is top reinforcement, bottom reinforcement and shear reinforcement. For each beam across 12 sections, what you can see in red is the required area of steel envelope, and also if you bring your cursor to at any of these locations, it will give you the area of steel required at that location. And what you can see in blue is the provided reinforcement. So here this graph basically gives you a feel of your capacity utilization and if across the entire group, so you can see whether your design is is more than required, exactly as tight as possible. Also you can edit here. If I wish to edit in this window, that is also possible by looking at a very detailed picture. So for example, if I want to apply this 420 plus 416 from this section even to this section here, I can just right click, I can say copy and come here to this zone and paste it. The reinforcement changes. The reinforcement at right was also 420 plus 216, so consequently it has given us one straight line running all across. So you can also see the variation in the graphical format. You can also do non-standard detailing if you wish to. So suppose I want to select two sections or up to L by 6 of this beam and try a different detailing. So I can select those, right click, say detail, and so I want to make it 420 plus 420. I just accept it. So the reinforcement changes here and the graph changes to display the provided reinforcement. Now I can, if I want to apply this reinforcement to the right, I can select this one's location, copy from that location, select multiple locations here and say paste. Two things will happen. One, the reinforcement obviously get pasted after checking for sufficiency. Also, since it's a continuous support, the other side of the continuous support has also changed to reflect the change in one side. So at all points in time on two sides of the continuous support, it will ensure that the reinforcement is the same, so that the continuum is established at all points in time. So you have a very detailed view also, where you can actually view your detailing and edit it if you wish to, but definitely you can take a look at the capacity utilization. So it's a very, very powerful tool which helps you envisage your detailing in much better graphical environment. We through design and detailing, like in columns, we can go into the various reports. So I can go into reports. There are 2 CAD reports and 3 or 4 text reports. I can go into a schedule. Just click a button, so it will generate a schedule. There you are. So the schedule is got generated. I can just zoom on this and view the schedule. So it gives me the schedule of all the beams. Now you can also see the beam, by default it is given material property M30 for FE415 because that was a general setting, and for a few beams we have changed that. So that is come in the remarks automatically here that this is designed for M25 and not for M30. So it will reflect that. So it's a very dynamic and live kind of drawing that is generated. It's not a static representation. I can also go and generate elevations for one or all beams. I can say all beams. I can generate elevation and cross section, or either or both. I just click a button. Software will draw the elevation and cross sections. The drawing of cross sections is an intelligent task. What it does is scans the length of the beam, and wherever there is a change in cross section, it will give you a new section. So first section at the left end, and as you go towards the beam, wherever and how many number of changes in the reinforcement happen, it will give you so many sections. So there you touch a button, all 15-20 beams, elevations, cross sections are all drawn to scale, to size. We can just zoom this with everything, spacer bars, the bend shown to scale, everything, scale, shear reinforcement, indicative grid lines, everything. And we can also zoom to show the cross section, so the cross section, so stirrups, face reinforcement, everything. In case you're using 4 or 6 legged stirrup, it will give you those. Or this is perhaps a different beam where you can find sections are changing, and since sections are changing, there will be multiple cross sections if you pan to the right end. So here you can find that there is a section from location A to B, B to C, C to D, D to E. So all those locations are also mentioned here. So this is a complete drawing giving you the entire beam elevation and all the nuances. Then we can go into reports. We can view design calculation reports. So I can come in and click one or multiple groups, and we'll give you a design of 6 sections in a vertical tabular format, but everything in detail. So type of beam, length, design code, moment, torsion, moment to torsion, etc. Shear, again everything. So shear to torsion for for the ductile design, dead load, live load, shear, hogging moment, everything. The various shear criteria, ductile criteria, SFR design, whether required or otherwise, spacing criteria for SFR. So very, very detailed information where everything is captured. I can generate a summary, a size change, quantity. So all the reports here on are similar to what we will see in columns. So this is a summary, which is a small design for the user to view. So shear, moment, PT calculated, AST, reinforcement, shear, SFR, very small, quick, concise reporting. So this is beams, again start to end, read, understand continuum, design, detail, draw, generate all the reports, all of it. Let's move on. Let's say I'll quickly take you to the alloy elements also. We'll quickly look at, say, slabs and footings also. Let's say we are going to a slab kind of environment, and let's start with ETABS, and let's say we pick up the same ETABS file. I go to slab and I select a slab, say story 1. Here, whether you model or not, the slab are identified from the beam column geometry. So the software will identify the slabs. Here, as you can see, here we have not modeled anything in ETABS. A slaughter identified, or it could be in start, we never model slabs. Identified each small polygon, or the smallest of polygons, which could be slabs. It identifies its size, and based on the aspect ratio, the span type, and based on the actual continuum across around it, the panel type. So all of it is identified by the software, and all of it can also be edited by the engineer if he wishes to. If he disagrees with something that the software suggests, he can say, no, I don't want to design this with 2 edges discontinuous, I want it all 4 edges discontinuous. So I can just come and select that option, and design with that. So I have the freedom of doing that. Also what we can do is define if some slabs are cutouts, if some are sunk, etc. So let's say this slab here is actually a cutout. So I can select the slab, it gets selected in the table. In the table there is a column here, is it a row, is it a cutout? I just come and say true, it's a cutout. It gets generated as a cutout. For the next slab, let's say it is a sunk slab. So I can just say, is it sunk? I say yes. I say it's a sunk slab. So you can see the color changes indicating that it's a sunk slab. So you could have sunk slabs, you could have raised slabs, etc. And once we change all of this, the continuum of the slabs around it has to change. So even if we try to design now, the software will come and say that the factors affecting continuity have been changed. So we need to reevaluate the continuum. So to do that, I'm going to modify and say reevaluate the slab continuity. So to reevaluate the continuity of the surrounding slabs, come back and give us a modified option. And from here, now we can go into design. Let's say I want to provide loads, so I can provide some live on imposed loads. I can select them and paste it, and I say design. Each column will design and detail for deflection, shear and flexure. So it's a detailed, everything considered. The design, as you can see, gives all information. So thickness, material property, bottom steel in both direction, top steel at continuous and end supports, distribution steel, etc. So all of it is displayed. And there are a lot of smart tools like in beams and columns where you can copy and paste design, reinforcement, or you can copy entire design itself, or copy the thickness and select the thickness, design other column slabs with the same thickness. Or you can go to any one section, go to design and rework the design by changing either the size, material property, size, the panel type, loading conditions, everything. So all can be controlled by the user at multiple levels using a lot of interactive tools. And once we are through with the design and detailing, it gives us a host of reports. Slab schedule so I can generate a schedule or a touch over button. I can generate an interesting output called in-plan detailing. So now we've actually didn't set the design parameters. The default curtailment type or reinforcement type for slabs is curtail bar, so separate bottom and top mesh. In case you wish to work with a bent up kind of a system, there is also that system. So if I go into settings, which we actually glossed through, you can either do curtail bars or bent up bars. So if you do bent up bars, the drawings etc. will come as per the bent up style. So this is a curtail system wherein this is bottom steel, so you can see some bars are full, some are curtail as per design. All bars are designed in detail. You get the top reinforcement. You can actually see both together if I put them next to each other. So bottom reinforcement and top reinforcement both. So this comes out directly from your design and geometry right from analysis. So at a touch of button. So this is detailed output. I can close the schedule also. You can draw a slab section. Suppose I want to, you can define how many sections of cut slabs you're cutting through, say 3 slabs. Define the slab, let's say I'm cutting through S1, S2 and S3. Define the support. So this is a support called B1, which is 230 by 450 deep. I can just copy the beam sizes and give B1, B2, B3 and B4. Give it a section mark A and I say draw. So touch a button, the section gets generated. You can then go and view that in greater detail. So it gives you the top curtailment, bottom curtailment. If alternate bars are curtailed, it will say alternate reinforcement curtailed. If they are bent up, alternate reinforcement would be bent up. So all down to scale mentioned in the drawing. We can also draw a section of a staircase, and it's very versatile. You can have multiple different beam size at bottom, top, landing. You know, different location of the beam. The beam could either be at the intersection of the landing and the flight, or at the end of the landing slab. So it could be at the end of the landing slab or the intersection of the beginning of the landing slab. The beam could be downstand or top upstand. Sometimes mid-landing beams are upstand. And you can define various flight dimensions. So the number of rises and treads, the span for the flight can change. And you can also give different bottom and top landing. So they also don't need to be the same. It could be some bottom landing could be different from the top landing. And let's say S13 here, which is 280 thick. I say is a staircase. So click a button, I get a drawing of my staircase. So the staircase will have all the detailing is in principle adopted from SP34. So there is a detailing guideline that we've used. So this is my upstand beam. This beam could be at this location or at the junction. The detailing will change. So around 6 different type of detailing options can be simulated depending upon the various support criteria. And further, the other reports such as summary calculations etc. can be generated. So in slab I can go to any slab and detail generate a detailed calculations report. So like design for moments, shear, reflection, all of it comes in. This is slabs, and I'll just quickly run you through footings also. So I can put, say, project sample, client as SQ, and let's say I pick a start file now for variation, and I say I want to design a footing. I say OK. It reads all the geometry, identifies all the supports for all the columns which could have a footing. The user can define the footing type here. So by default, all of them are pad. You could choose to change them, and let's say we can call these two sloped. Some can be pad, some could be step footing. So you can have different step footing options. You can group footing. So I can go to group and group columns and see group these two, create a group. So I get a group of these two which will be designed for worst case scenario, and set a whole host of design settings. So everything from SBC, so I can, let's say SBC is 400, soil density, etc. I can decide when I want to work with net SBC or gross SBC. Do I want to design with overburden? Do I want to check for buoyancy? Do I want top steel? Do I want to provide faith reinforcement? They are optional. You can define your planned round-offs. So all the dimensional round-offs, material properties, SBC increase factors, PCC offset, PCC thickness, all of those settings can be done. You can go and set the various reinforcement settings. So minimum and maximum percentage steel, rebar diameters, bar spacing, everything can be controlled by the user. And now I just go and say design. Like before this, associate the load cases. So this is dead, this is AQX, this is AQX, this is AQZ. For footings, we use load combinations which are factored as well as unfactored. Factored are used for the section design, cross-section design, and unfactored for the plan area design. So let's say I have my design combinations in analysis, so I can just say add from analysis. Sizing I have not created, so I can go to sizing and say add from template. So I say add from template for regular structure without the cross combinations. Irregular would give me cross combinations for earthquake. Without cross combinations, it generates the combinations. I say OK. It will design and detail all the footings in hardly any time. It will give you a footing layout drawing. Once they are designed on the right, you can see a footing layout drawing wherein each column, let's say we just see only the footing. So everything with footing, size, layout, PCC, all marked. We can go to the design input, I can go to the design output, so it will give you all the information, type of footing, steel, size, etc. The user has the total freedom to redesign anything. So when I go to a redesign option, I can change the type of footing, I can change the size of the footing, I can also change all the design settings that we have done, including SBC. So for a given footing, I can have a different SBC. So you design and actually dig and find out a much higher, much higher SBC, you can go in and edit it and apply that. So that option is also available to the user. I can edit anything I want to. Once I'm through, I can generate a host of reports. So I can create a detailed drawing. So I can select footings for which I would want detailed drawing. So let's say this is OK. It gives me a detailed drawing. I can just merge them to view that detailed drawing. So if I zoom here, this is my slope footing with reinforcement. So reinforcement shown in the plan. This is the cross section with the reinforcement, showing column reinforcement also, cross section in the other direction. This is a step footing, so you can see the section of the step footing in both directions. This is because we designed with top steel. Had we chosen to design with top steel, obviously the top steel would not have been displayed in the drawing. And finally we can see the normal pad footing, direction 1, direction 2. So this is footing, then you can generate a schedule for footings, design calculation reports, quantities. This is my schedule, so you can just zoom in. The footing column, type of footing, size, steel. If there are steroids, if you can design with shear reinforcement if you wish to. If you want to control the depth of the footing, you can design with shear reinforcement. You can go and design calculation reports, which are very detailed, covering everything, minimum file pressure, maximum file pressure. It gives you design for bending in both directions, punching shear, load transfer, normal shear in both direction, one-way shear. So all aspects are considered. For a step footing, you will get shear calculations at every step. So at the face of every step, it will do punching and shear calculations. Nothing is left to chance, very exhaustive, all taken care of. The software comes with a very detailed and exhaustive help, which is very graphical in itself. So if I go to columns, let's say it starts with a technical discussion of what are the technical settings, and then it takes you through the entire process pictorially, like an operating manual. So it's impossible to miss anything. It's not a very unduly, unnecessarily theoretical kind of option. So everything is displayed. And as I mentioned before, I can actually create my own drawing style. So if I want to have my layers, colors, fonts, etc. So before I start the software, I can go to File, go to Drawing Style, and say go to this tool called Launch Style Manager. So here, for each of the elements that we are using, what you can see in gray are the various layers that the software generates. You can define the description of the layer here. You can edit this. You can define the color that you want to use. You can define the color palette, pick up from it. You can define the font that you want to use. You can define the text height, all of it. And once you're through, it creates a drawing style. You can set it as your default style. So here at the bottom right, you say there's a drawing style called default drawing style. As you create your own style, you can set your style to be default. So every time you work with it or you generate an output, the drawings will be in your layers, colors, and fonts. So this in a nutshell is what I think what RCDC is all about. If you have any queries, questions, I would love to take them. Also, you can pick up a demo CD and explore the software to get to know it better before you can decide whether it works for you as a solution in itself.